Section 8.1 is about the product rule and the power rule for exponents. So we're going to learn the properties of exponents. The first property is the product property, which says that if you have x to the a power times x to the b power, it's the same thing as saying x to the a plus b power. So what that means to us is that to multiply powers with like bases, so again, the base is the big number, so the x and the x, if those are like bases, all you have to do is add the exponents, which are the little numbers. So we'll add a and b. Okay, then we have our next property, which is the power property. And the power property says that if you have x to the a power and you take x to the a power to the b power, then you're going to multiply your exponents. I think of it like this. You have a parentheses here, so you're going to distribute the b. So a times b, right? So that means multiply. So for us, what this property means that if we raise a power to a power, so exponent and then another exponent, we multiply the exponents. Let's look at an example. Let's look at an example where we add the exponents. We have x to the fifth times x to the second power. So the bases are the same, so we add the exponents, 5 plus 2, which is 7. So our answer is x to the seventh power. Let's do an example where we have to multiply the exponents. Here we have x to the fifth power to the second power. So again, it's like the distributive property, 5 times 2, and 5 times 2 is 10, which means that we have x to the 10th power. Now let's talk about order of operations. If you have to raise a power and you also have to multiply, remember that exponents come before multiplication. So you're going to do the raising to the power, the multiplying part, before you do the multiplication part, which is the addition. So for example, if you have y to the fourth times y to the third to the second, the y to the third has a power of 2. So remember, you're going to distribute first. 3 times 2 is 6. Okay, so you're going to do that piece first. Okay, and once you've done that, now you've got y to the fourth times y to the sixth. And now you can add those exponents. 4 plus 6 is 10, giving us the answer y to the 10th. All right, let's look at some more another example, example 2. Let's talk about the commutative and associative properties of multiplication. So remember, commutative changes the order, and then associative changes the groupings. Okay, so we have 3 times x to the second power times 5 to the x power. So what I want to do is I want to put my 3 and my 5 together, which I can do that with the commutative and associative properties. So now my 3 and my 5 are together, leaving me x squared and x, which is x to the 2 plus 1, because the bases are the same. And of course, x to the 2 plus 1 is x to the third, and 3 times 5 is 15, giving me my final answer of 15x to the third power. You might be wondering, where did this 1 come from? The 2 plus 1, where did that plus 1 come from? Well, you have to remember that x is the same as x to the first power. There's an invisible 1 right there. So this 5 to the x is really 5 to the x to the 1 power. So we've got 2 plus 1. All right, let's look at this example. We have negative 8x squared y z cubed, and then we have xyz squared. Okay, so what we want to do is we want to get everything together. Okay, so I have a negative 8, but I don't have any other numbers. So negative 8 is just going to be by him lonesome. My next grouping is my x's. I have an x squared in that group, and I also have an x in that group. So x squared times x. Now I go on to my next group, which is y. I have one y here, and I have another y here. So for my group, I have y times y. Now for my z group, I have z cubed and z squared. So in my z group, I have z cubed times z squared. Now that I've used the commutative property and the associative property, now I can go ahead and add my exponents. So now I've got -8, and then x squared times x. And remember, there's an invisible 1 right there, so I've got x to the 2 plus 1. And then for my y group, both invisible 1s, so y to the 1 plus 1. And then for my z group, I've got z to the 3 plus 2. Giving me my final answer of -8 times x cubed y squared z to the 5th. All right, next example. Let's say we have -ab squared cubed. So remember, this is a power to a power, and this cubed means that everything in the parentheses is going to repeat 3 times. So -ab squared times -ab squared times -ab squared. Okay, so remember the negative is really a -1. So I've got one -1, two -1s, three -1s. So I got -1 times -1 times -1. And then for my A group, I have 1, 2, 3 A's. And then for my B group, I have B squared, and B squared. So -1 times -1 times -1 is -1. And then my A times A times A is A to the 1 plus 1 plus 1 because each A has a 1 on it. And then B squared times B squared times B squared is B to the 2 plus 2 plus 2. Giving me my final answer of -A cubed B to the 6th power. All right, so commutative and associative properties can also show that the power of a product is equal to the product of the powers. So if I have A, B, C to the nth power, I can basically distribute that power. So it's gonna go to each exponent. So I have A to the n, B to the n, and C to the n. If A already had an exponent on it, then I would multiply that exponent by n. Let's look at an example. Let's say I have -2 m to the 4th n, and all of that is cubed, and then I have 1/6 m n squared, and that piece is squared. Okay, so first thing I want to do is I want to distribute these powers. So here's this 3. That means -2 is going to get to the power of 3, so -2 cubed. And then m to the 4th is also going to be cubed, so I have m to the 4th cubed. And then n is going to be cubed, so now I have n cubed. Okay, now I'm going to do the same thing with this group because this whole group in parentheses is getting squared. So I'm going to distribute that squared. Okay, so now I have 1/6 squared, I have m squared, and then I have n squared squared. Okay, now that I've done that, let's go ahead and do the power property, right? So -2 cubed is -2 times -2 times -2, which is -8. And then m to the 4th to the 3rd, well, remember, this is 4 times 3, so I've got m to the 12th. And then n cubed is just n to the 3rd. And then 1/6 squared is 1/6 times 1/6, which is 1 over 36. And then I've got m to the 2nd power, which is m squared. And then n squared squared, so remember we multiply those, so 2 times 2 is 4. So I have n to the 4th. Now I want to put my groups together, right? So I have -8 and I have 1 over 36. So we want to put those next to each other. And then I have m to the 12th and m to the 2nd. So those can definitely be put together. So I've got m to the 12th plus 2. And then I got n cubed and n to the 4th. So those can be put together. So I've got n to the 3 plus 4. So -8 times 1 over 36 reduces to -2 over 9. And then I have m to the 14th and n to the 7th as my final answer here. All right, next example. Let's say we have x squared x y squared plus 3xy x squared minus 5x cubed y squared. So the first thing we want to do is simplify each term. For example, x squared x y squared, this x squared and this x, that can be simplified, right? That's going to be simplified to x cubed. So now I've got x cubed y squared. And then in the second term, this x and this x squared can be simplified. So I'll have 3x cubed y. And then in my last term, nothing can be simplified. So it's just going to go ahead and be there, minus 5x cubed y squared. And now that I have simplified each term, I want to combine like terms. So remember, in order to combine like terms, the exponents have to be the same for the individual variables. For example, x cubed can only be combined with another term that has x cubed, which everything does. But it also can only be combined with something that has a y squared. And this second term, the y is not squared, so I cannot combine my first term and my second term. However, I can combine my first term and my third term. And when I do that, this is 1x cubed y squared minus 5x cubed y squared. So 1 apple minus 5 apples gives me negative 4 apples. So negative 4x cubed y squared. And then I still have that plus 3x cubed y that could not be combined. So it's your turn. You're going to do 2 through 6 evens on 8.1.